Hello everyone, this is Dr. Nimish Kumar Srivastava, Assistant Professor in AKGEC Engineering College, the Department of Electronics and Communication Engineering. So in this today's lecture series of covering the complex topics, we are going to discuss the topic which is considered to be one of the most difficult part about the concept related to a latch and the flip-flop. So we will discuss about what is latch and what are the different types of a latch. We will basically concentrate on SR latch, and from that, as building the concept of SR latch, we will slowly move on to the concept of flip-flop, why we require flip-flop. And once we build up these two concepts, we will try to discriminate between the latch as well as the flip-flop. So now let's first start with the concept of your latches. So in this latch is basically called as a cross-coupled device. So we will try to point down some points. And latch, so it is a cross-coupled device. I mean a device which is formed by connecting a cross-coupled gates. So if I am saying that a cross-coupled gates, so how it will look like? So your latch basically implemented by using NAND as well as a NOR, and so with the help of a cross-coupled, what is the meaning? So this is the meaning of that cross-coupled. So the output of the first, the output of the first NAND gate is connected as an input to the another NAND gate. So that is a cross-coupled device. So this is a latch by using NAND gate. So it is a latch by using NAND gate. Similarly, the another types of or the latch which can also be implemented by connecting a NOR gate in a cross-coupled manner. So exactly the same situation will be for the NOR. So this is your latch implemented by using NOR gate. So this is the concept of the latch. So latch is a cross-coupled device. So whatever the inputs that we are providing at the latch, the input terminals, so based upon the inputs, it will react, it will produce the output. So that means there is no kind of any triggering that is required here. Latch, that means a clock pulse, no clock pulse is attached with the latch. So whenever the input is provided, whenever you are feeding the input, so based upon that inputs, it will produce the output. So that is something called as a latch. So now once we got this concept about what is latch, it's a combinational or a sequential circuit which is formed or which is designed by connecting gates in a cross-coupled manner. So that is implemented your latch as well as by using a NAND as well as the NOR implementation. Now the next thing is that we have to build some concept. We have to build some. We have to be familiar with some basic terminologies which is associated with the latches. So now these terminologies not only associated with the latches, but they are equally valid for the flip-flops. So we have to go through those terminologies very carefully, and those terminologies are, let us first design that latch by using NAND gate again. So this is a NAND gate connected in a cross-coupled manner. So this is some terms related to the latch: Qn plus 1, Qn plus 1 complement, and this is Qn, this is Qn complement. Similarly, these are the inputs. If I am calling it by a name A and B, so this is my two inputs that I am providing. Now we are seeing that we are having three terms. First is Qn plus 1. So this Qn plus 1 is called as a present input, right? Present input. So this is your Qn plus 1 is present normal input. Why I am saying normal? Because we are considering as something in normal form as like Q, and its complemented form we will consider it as a Q bar. So that is your present normal output. Similarly, this is called as a present complemented output. This is your present complemented output. Complemented output. Now the thing is we are having another terms which is your Qn. So if I am considering Qn plus 1 as my present output or present normal output, so definitely what will be its past will be Qn. So it is your past normal output. This is past normal output. Similarly, this Qn complement is called as a past complemented output. Past complemented output. And these two terms, that is A and B, this is your present input. Present input. So this whole figure depicts the sequential circuit. In a sequential circuit, we have understood that what is sequential circuit? It is a circuit whose present output not only depends upon the present input but also on the past output. So this Qn and Qn complement are the past output, Qn plus 1 and Qn plus 1 complement are the present output, right? So these are some important terms which is associated with the latches as well as which is associated with the flip-flops. Now, whenever in your exam a question is asked like explain the working of a latch, or explain some, it will be some not only latch, it will be based upon SR latch, and similarly it would be based upon SR flip-flop. So in that case you have to concentrate on the present normal output. Even if the exam is in the exam they are asking them what is the output of this flip-flop, they will give you some figure, and in that figure they will ask what is the output. So if they are asking like what is the output, so you have to concentrate on the present normal output. They are asking this value, present normal output, not the Qn plus 1 complement form, right? So always concentrate on Qn plus 1. This is the present normal output, or they will be, it will be something you can call it as a what is the output. So if you are asking about the output, so it will be a Qn plus 1. Now once we got this basic concept of the terminologies associated with the latches, now we have to move into some more details of the latch, that is what are the different possible states, right? Different possible state possible for the latches. So this possible state which is the different states which is possible for the latch, that equally valid for the flip-flops also. So we will very carefully see what are the different states. So we will concentrate on the different states. So first that we are going to discuss is about the hold. Hold state. In the case of hold state, if I am saying that my latch is in the hold state, so what is the meaning of that? I am concentrating on the present normal output. So what is the value of a present normal output based upon which I can say that my latch is in the hold state? So if your Qn plus 1 equals to the Qn, or your Qn plus 1 complement equals to the Qn complement, in this case we will say that the latch is in the hold state. Means that the latch is holding the past value of the output, right? So if your latch is holding the past value of the output even at present time, then we will say that a latch is in the hold state. Next state is, so let us try to write down these different states with different colors. So first is your hold state, another is called as the set state. So obviously by this word set means that when we are saying any device to be in a set state, means that the output should be 1. Only then we will say that that particular device is in the set condition, right? So means that if I am concentrating on the present normal output, so that present normal output value should be 1. Then I will say that my flip-flop or my latch is in the set state. So this is your 1. So if Qn plus 1 is 1, means that its complement will be 0, or Qn plus 1 complement equals to 0. So this is the another possible state for the latch. Next possible state that is possible for the latch is reset. Reset state. Now in the reset state, obviously by having this, by seeing the word reset, one can easily conclude that its value, output value is 0. So if Qn plus 1 is 0, definitely Qn plus 1 complement will be 1. Similarly, another possible state is toggle state. In toggle states, just remember that toggle is just the opposite of the hold. Hold was the condition in which we are saying that a latch is in the hold state when it is holding, when the present output is holding the past output value, then it is a hold state. So if it is just the reverse of a hold state, means that Qn plus 1 equals to Qn complement, or my Qn plus 1 complement equals to the Qn. So that is the condition for the toggle state. Now the last state that is possible for the latch is called as the invalid state. Invalid state. Invalid state. In the invalid state, the condition is Qn plus 1 equals to the Qn plus 1 complement. Then we will say that a latch is in the invalid state. Why we are saying that the latch is in the invalid state? By just visualizing the output Qn plus 1, which is equal to the Qn plus 1 complement. It is something like we are saying that 1 equals to the 0. Is it possible that 1 is equal to the 0? Totally not possible, right? Because suppose that Qn plus 1 is having the value of 1, and by this equalization terms, we will say that 1 equals to its complement, which is equal to the 0. So it is totally not possible. So that means 1 cannot be equal to the 0. So that is the condition in which we will say that a latch is in the invalid state. So these are all the possible states for the latch as well as for the flip-flop. This is very important concept related to the latches, because these are the different states in which a student get confused, like in which state I am going to call it as a toggle, in which state I am going to call it as a hold, or in which state I am going to call it as an invalid state. So these are all the possible conditions that one have to remember in order to easily get the concept related to the SR latch, SR flip-flop, JK flip-flop, and the remaining flip-flops. So this is the very important concept related to the latch. Next thing is about the basic latch that we are going to discuss is the SR latch. So we will discuss the basic latch, which is your SR latch. This is your also called by name set reset. S stand for set, R stand for reset. So it is a set reset latch. Now how we are assigning a name to the terminal, like if I am saying that I am having a, SR latch by this configuration. This is my SR latch. Right, so I am having a input AB, I am having my output Qn plus 1, similarly Qn plus 1 complement. So these are my outputs, and similarly my Qn and Qn complement. Now I am having two inputs. I'm just assigned a name as A and B. Now, which terminal should I call it as a set and which terminal should I call it as a reset? Now, that thing we have to visualize by using the truth table. Based upon the truth table, we will conclude that my terminal A is reset or my terminal A is set. So, let us start with that concept. So, in this we have considered we are going to design a SR latch, its truth table. So, for that we are just considering terminals as AB. So, we are going to give different values for AB 00, 01, 10 and 11, and based upon that we will visualize what is the output. Once we got the output, we have to understand whether we have to give assign or whether we have to assign a name of a set to A or whether we have to assign the name of a set to B. So, that is the first thing. So, I am just redrawing it again, or it would be better. So, we are having two terminals A, B, and we are having output Qn plus 1. Similarly, we will write the states, possible states. So, this is my truth table for the SR latch. All the possible input combinations 00, 01, 10 and 11. Now as this is my NOR latch or my NOR gate, latch which is formed by using a NOR gate. So concentrate on two concepts related to a NAND as well as a NOR. The concept is, if suppose that I am having a NOR gate and out of that two terminals of a NOR gate, one terminal is whose value is provided or whose value I can give the value, and the other terminal I don't know the value of the other terminals. I only know the value of the first terminals. Just try to relate this thing. So these two terminals are there, and without knowing the value of the second terminal, what is the value that which I should consider so that I can predict the output of a NOR gate without even knowing the value of the other terminal? The concept is this one, right? I don't know the value of the second terminals. So what is the value of first terminal that I should consider so that I can get a fixed output without knowing the value of the second terminal? So that value for the NOR gate is 1, because if we have provided the 1 as an input to the NOR gate, irrespective of the other value of the irrespective of the other terminal value, the output will always be 1, because what is the another value or another terminal value could be? It could be 0 or it could be 1. I don't know what is the value, but I have fixed the value of a first terminal as 1. So even if the second terminal value is 0, I will get 0, because 1 plus 0 and complement of that is 0, and 1 plus 1, the complement of that is also going to be 0. So that is the value for which I have to first get the output. So means that what are the different values where I can get different possible combination where I can get the values as a 1? It is I am having the 3 possible combinations. So I can directly predict the output for all these 3 combinations. So let us try to first write those values. So first I will consider the combination as, I'm going to consider the combination as my 0, 1. Now I know that we have just discussed that we have fixed the value as 1, so I can directly predict the output is 0 based upon this value. It is 0, right? Now this 0 is taken as a feedback and given to 0, so that combination will be 0 plus 0, output will be 1. So that means for combination 0, 1, my output is 1. For combination 0, 1, my output is 1. this one. Fine. So this is the first combination for which I got the value. Now this Qn plus 1, I am getting the present normal output value as a 1. So that state is called as a set state. So this is my set state. Next thing, now let us try to reverse the value. One, 0. So its value will be 0 and 0 taken as a feedback, and its value will be 1. So for the combination 1, 0, I am getting my normal output value as 0. So that means it is 0. What is the state called? It is called as a reset state. Reset state. Let us try to visualize the third possible combination in which I can get 1. So both inputs are 1, 1. So if both are 1, 1, obviously it will be 0, 0. So that means Qn plus 1 is 0, as well as Qn plus 1 complement is also 0. So this state is called as a invalid state, because at this point I am getting Qn plus 1 equals to my Qn plus 1 complement, which is totally not at all possible. So that state is called as the invalid state. So this is your invalid state in which both Qn plus 1 and Qn plus 1 complement value is 0. So this is my invalid state. Invalid state, right, which I will denote by cross. Similarly, the first case is left, that is 0, 0. So let us try to visualize that case also. And both the input are 0, 0. In this case, in order to get the output, we have to be very careful. Like suppose this is, I am considering this first term, that is 0. So with this 0, I am giving first terminal input as 0, and here we are getting Qn complement. Here we are getting Qn complement. So 0 plus of Qn complement to the whole complement, that is 0 plus of Qn complement to the whole complement, which will be written as Qn. Similarly, if suppose I am considering this one, so it is what? It is 0 plus of Qn to the whole complement, which is equal to Qn complement. Means that at present I am getting Qn plus 1 equals to Qn, as well as Qn plus 1 complement equals to the Qn complement. So this is the value that I am getting, and this state, as we have discussed, is called as a hold state. Fine. So let us try to complete our truth table. So that means Qn plus 1 equals to Qn, and this is called as hold state, right? So that is the description for the SR latch. Now another thing that we have to conclude is what is the name that we have to assign to A and B. So in the case of a NOR latch, we have considered the inputs 1, because by giving the input 1, regardless of the another input value, I can easily predict my output. So that is 0. Now in this case, so I have to concentrate on inputs 1. So I will concentrate on input 1. So how to assign the name? Just remember that discard the combinations for which I am getting inputs as same, like I am getting giving both the input value as same value, like 0, 0 and 1, 1. Concentrate on the values, on the input combinations at which we are given the different values. So we have to concentrate on those two values. So that means 0, 1 as well as 1, 0. And in the NOR case, concentrate on the terminal or concentrate on the value 1. So for these combinations, like first, that means second and third, have this concept that what is the value that I am giving to a terminal B or that I am giving to a terminal A. I am giving a value 1. Now based upon that value, visualize that whether the latch is in the set state or is in the reset state. So if I am giving value 1 to my terminal B, I am seeing that my output is 1, which is set condition. So that means my B will be set terminal. Another thing, by giving a value 1 to my terminal A, I am seeing that my output is 0. So that means if you are giving an input to a terminal and based upon that value, your latch is entering into reset state because its output is 0. So that's why it will be named as reset, right? So from here we are coining the name reset to A and set to B. So that means my exact figure for the SR latch using NOR gate will look something like this. So this is my reset and this is my set terminal. This is Qn plus 1. This is Qn plus 1 complement. This is Qn and this is Qn complement. Fine. Now let us try to build some more concept, like how we can say that it is a hold or it is an invalid state. And we have considered the input, that means terminals that going to react only for a value 1, right? So let us see how we are saying that hold and invalid state. We have given the name reset to A and set to B. Now let us visualize the term hold. It is something like your R equals to 0 and S equals to 0, and we have considered that your latch going to react only for the input 1. So it will consider, or whenever we are giving 0 to this R and S, it is waiting for the input to be given because it is reacting only for the input 1. So for S is equal to 0 and R equals to be 0, R equals to 0, your latch is waiting for the input to be given. So if it is waiting for the input to be given, it will hold the past value because some based upon some time your latch must be having some output. So that output will be continued at present also. So that is your hold state. Similarly for the invalid, right? For the invalid, we know that R equals to S equals to 1. Your R is reset and your S is set. If you are giving both the input terminals value as a 1, you are at the same time telling the latch to enter into a reset state as well as enter into a set state at the same time. Is it possible? Totally not possible. We cannot just trigger the, we cannot just force the latch at the same time to behave like in a different manner. By giving the input as a 1 to both the terminals reset and set, we are saying to a latch, okay, now just at the present time enter into a set as well as in a reset state. So it's not possible, and your flip-flop get confused or your latch get confused. So that is called as a invalid state, right? So that is something related to the SR latch using the NOR gate. Similarly, we will see the SR latch using the NAND. So let us try to visualize that thing also, SR latch using NAND gate. So SR latch using NAND. using NAND gate. So in the SR latch using NAND gate, as we know that it is a cross coupled device. So this is something like this, and it is Qn plus 1, Qn plus 1 complement. This is Qn and this is Qn complement. And again we are going to assign a name as A and B. Based upon the truth table, we will conclude whether it is a reset or whether it is a set. Now, so again we will see the truth table for SR latch using NAND gate. So we are having two terminals A, B. We are having output as Qn plus 1, another as Qn plus 1 complement, and the state. We will consider all the combinations one by one, and based upon that, we'll try to coin the name of set and reset to A or B, 0, 0, 0, 1, 1, 0, and 1, 1. Now, in the case of a NOR, we have considered the combinations 1, because by giving a combination 1 to one terminal, I can easily predict my output. Now, what is the value of input that I should consider for the NAND gate, so that without knowing the value of other input, I can easily predict what will be the output? So that value is 0, because if you are giving one terminal value as 0, irrespective of the other terminal value, you can directly predict what will be the output. It will be 1. So concentrate on the values for which, concentrate on the input combinations for which we are having a 0. So we will try to first visualize that thing, and suppose I am writing the value as 0, 1. So in this case, its value will be directly 1, and this 1 is given as this input terminal. So 1.1 a whole complement, that will be equals to 0. So for combination 0, 1, I am getting Qn plus 1 as 1. I am getting Qn plus 1 as 1. So its complement will be 0. So what is the name of this state? It is called as a set state. So we will consider another combination. We have considered 0, 1. Now we will consider 1, 0, 1, 0. So its value will be 1. This 1 is taken as a feedback, 1.1 whole complement, which is equal to 0. Now for combination 1, 0, I am getting my output as 0. This is 0. So its complement value will be 1. So that means it is your reset state. Fine. Now the another combination that is left is 0, 0. So let us try to visualize that combination also. So 0, 1, 0, 1. So we are getting Qn plus 1 and Qn plus 1 complement, both value as same, that means 1. So that is 1 and 1 for giving 0, 0. So this state is called as invalid state, because both normal and complemented form is having the same value, which is totally not possible. Now the last combination which is left is your 1, 1. So we will try to visualize that thing also. One and 1. Now for 1, 1, if I am considering the upper two terminals, so this is my Qn complement, so its output will be 1 plus Qn complement to the whole complement, which is my equals to Qn, right, which is equal to the Qn. So similarly, if I am considering, this is not plus, but it is dot. So this is my Qn. Now similarly, for this case, if I am considering the bottom two terminals, So it is my Qn is coming here as a feedback. So its output will be 1 plus Qn, or sorry, 1 dot Qn, 1 dot Qn to the whole complement, which will be Qn complement. So means that my Qn plus 1 equals to Qn, because both are having the same value. Similarly, at this point, my Qn complement, Qn plus 1 complement equals to Qn complement. So this is the state which is called by a name hold state. So that means for this value, I am getting my combination as Qn, and this is Qn complement, and this is called as a hold state. Now once we have just drawn the truth table, now we have to assign the name to A and B. And in the case of a NAND, we have considered the value for which we can easily predict the output is 0. So that means we have to concentrate on the input combination zeros. And in the earlier case of NOR gate also, and that is a latch using NOR gate, we have discarded the combinations, that means equal combinations, means giving the same value to the input terminals. We have discarded those combinations. Same strategy we have to apply here also. We have to discard this combination, discard this combinations, and concentrate for which we are giving different values to the input terminals. So that means 0, 1 and 1, 0. We have to concentrate on these two values. So in the case of a NAND, we are concentrating on the zeros, because by giving one input as 0, we can easily predict the output as a 1. So we will concentrate on zeros. So we are concentrating on zeros. Now that means your SR latch using NAND gate going to react only for the input value 0. There is a difference. You can easily see the difference between the SR latch using NAND, SR latch using NOR. In the case of SR latch using NOR gate, we have considered that the NOR latch going to react only for the input 1, whereas in the case of a NAND latch, it's going to react only for the input 0. So that means just concentrate for the values zeros and observe that by giving a value 0, whether your latch is in the set or in the reset state. So I am giving 0 to my terminal A, and I am seeing that my output is 1, means that it is terminal can be, its name can be set as, name can be coined as a set. So this is your set. Similarly, for B, if you are giving input to a B as 0, observe the output, it is 0. That means that means B can be named as a reset. So that is reset. Now one more thing that we have to be very careful is that it is 0. That means it is active low. So there should be a set bar and reset bar, right? So that is the way by which you can coin the name reset or a set to the terminals A and B. So now we can write the name to our terminals A and B. So I will write the name So this is my set complement and this is my reset complement. So this is my complete description of a SR latch using NAND as well as a SR latch using NOR gate. So let us conclude one thing. SR latch, so we will consider those two combinations like using NAND as well as using NOR. So this is my first combination of first pattern of getting the latch or design. So this is my NAND latch and this is my NOR latch. That means SR latch using NAND as well as using NOR. So this is my, this we can write it as set as well as the reset. So this is my set and this is my reset. Similarly, this is my reset and this is my set, and this is Qn plus 1, Qn plus 1 complement. This is Qn plus 1 as well as Qn plus 1 complement. So this is my SR latch using, so we have discussed the SR latch using NAND as well as using NOR gate, and we have discussed about the how we can assign, how we can coin the name to be as whether reset or as a set. So the next thing is related to this topic is about how we can draw the truth table. So quickly let us visualize the thing. We are having set, that means SR latch using NAND as well as SR latch using NOR gate. So we are discussing for NAND and NOR by using NAND and NOR. So in the case of a NAND, we have discussed that it is set complement, reset complement, and your Qn plus 1, Qn plus 1 complement. Similarly here we are having R S and Qn plus 1, Qn plus 1 complement. So these are all the possible thing which is available with the SR latch in the case of NAND as well as NOR. So 0 0, 0 1, 1 0 and 1 1, again 0 0, 0 1, 1 0 and 1 1. So in the case of this one, that means we are at the same time giving input to the set as well as a reset. So that is your invalid state. So the better thing is, so in the case of invalid state, in the case of invalid state it is 1 1. Now similarly for giving 1 in 0 as to this set, it will be 1, it will be 0, to this it will be 0 1, and when we are giving 1 1, that means waiting for the input to be given, so it will be Qn and Qn complement. Similarly for NOR latch, we are concentrating on the value 1. So when we are giving 1, so it will be set, to this reset it will be 0, and when it is 0 0, waiting for the input to be given, so it will be Qn and Qn complement, and for this one it will be 0 0, which is your invalid state. So this is the truth table for the SR latch using NAND as well as the NOR gate. So with this concept we will wind up the complete discussion about how we can assign a name as a set or a reset to the latch. So this is the complete description about your SR latch using NAND and NOR gate, how we can assign a name, set or a reset to a or a B terminals, and based upon that what is the truth table, right? So that's all for this lecture series. So in our next video, we will try to discuss about the flip-flops. So thank you all for watching this video.